Hey, Mr. P here.
What's up, guys? It's Mr. Schmitz.
In this video, we're going to give an introduction to cellular biology, talk about some key players in the field of cell biology, at least early on in the field of cell biology, and identify the three components of the cell theory, as well as give a little overview of the advancements made in microscopy.
So let's get into it. To start with, we want to set the stage on what scientists and what the world believed about life prior to our understanding of cell biology. So when we think about cell biology, we got to understand that we're looking at a level below what the naked eye can see. And that created challenges early on in science. So we pose the question here, how are organisms produced?
Yeah, if you think about just going out on the weekend for a stroll in your local park or in your backyard, you typically see, like you said, organisms at the organism level, but we don't really see with the naked eye all of the microorganisms or the single-celled organisms or even the cells that make up the multicellular organisms that you see around the house or around the park that you're in. And so that posed a question, how are organisms produced? And early on, most scientists, or most people, because of the lack of scientific understanding at the time, thought that spontaneous generation was the thing, that living organisms were produced spontaneously or created spontaneously, really without any idea of
the mechanism.
Right.
How that happened. Like, for example, this beehive. We, at one point in our history, believed that these bees simply appeared because they needed to appear in this place to form this hive.
Right.
And so, spontaneously, bees would reproduce and produce more bees in that location.
Yeah, and we're not going to get into it in this lecture, but there were early scientists that literally thought by putting out raw meat or by putting out a spoiled carcass of a cow that they were butchering, that it just spontaneously produced bees or produced flies just because of the fact that they always saw the two associated together. We now know that spontaneous generation isn't a thing and that the raw or the decaying meat was just attracting the bugs. But at the time, they thought that they just spontaneously appeared out of thin air.
So how do we disprove spontaneous generation?
So there was a really famous scientist called Louis Pasteur that used another famous piece of equipment, the swan neck flask. He basically attempted to disprove spontaneous generation. He had hypotheses at the time that he didn't think spontaneous generation made sense. Most people accepted it as truth. However, because he was curious and because he was a good scientist, he wanted to disprove or at least try to validate the claim. And so he used this swan neck flask, which meant he was able to boil this broth, this nutrient broth that is conducive to growing bacteria. It is open to the air, so it is not sealed. However, because of this bent neck, it creates what we call an airlock, which means when he boils the broth and sterilizes it, he's able to keep it open to the air for as long as he wants. He kept it basically untouched for, I think, several years. No bacteria or mold growth occurred, even though it was completely open to the air, and that's because the microbes that are in the air that would get in and contaminate this sample were trapped in that airlock because they came in, kind of settled in this low spot and couldn't actually make it into the broth. It wasn't until he opened up the flask or broke the neck off, which opened it up to the microbes that could just easily fall in, and it immediately spoiled due to the fact that now the bacteria that were already there were able to use the nutrients and the resources within the broth to produce more cells, thus contaminating the sample. So, the big question, Mr. Schmitz, is spontaneous generation accurate?
Nope.
It is not. Thank you, Louis Pasteur.
So this experiment sort of drove some curiosity in other scientists to start investigating a little bit more about the production of life and maybe microorganismal life. And so what we're going to look at here is the development of what we would call the cell theory, which is our rules about cells that these scientists, which you see pictured here, contributed to. So we're going to talk through 5 different scientist contributions. We'll start with the man in the middle there, Robert Hooke.
And before you get into all of the individual contributions, just wanted to reiterate, when Louis Pasteur disproved spontaneous generation, it blew that field wide open, and it created, like Mr. Schmidt said, a ton of questions, and everybody kind of at the same time dove in and wanted to start answering the questions of how life arises, and what produces life, and how is life created, and how is life structured.
So we'll jump in with Robert Hooke first. Robert Hooke is the guy in the middle. He was the individual who is credited with naming the cell. So he gets the credit for naming the cell. He was looking at cork cells in a primitive microscope. Basically, he used some lenses to make a microscope, and from that was able to view cork cells, which cork comes from a plant. So it was plant cells he was looking at, which were rather boxy, if you know anything about plant cells. And so the reason he named it a cell was because it reminded him of the cells that monks in monasteries live in, sort of their rooms that they lived in, which is where the name came from.
Just to put this in perspective, the microscope he was using, I think, used candlelight, because this was prior to the light bulb.
Correct.
I'm not a big history buff, but I do think that checks out.
He was in the late 1600s, so yes.
So he was using candlelight and a couple of crude lenses to look at cells in a variety of samples and basically coined the term cell. Next is in the upper left corner, that's Antoine van Leeuwenhoek. He is now credited to be the father of microbiology. He took Hooke's simple microscope and made advancements to it and was actually able to see the first living cell. Because he observed the first living cell, he was then coined the term father of microbiology.
Do you remember what Anton van Leeuwenhoek was looking at when he looked at living cells?
I believe pond water.
Wow.
And, fun fact, he called them animalcules because it reminded him of tiny micro animals. We now know that they are not animals.
Correct.
And we no longer call them animalcules, we call them microbes.
Very good. Anton van Leeuwenhoek.
Antoine van Leeuwenhoek.
Van Leeuwenhoek.
And in the bottom right, we have Theodor Schwann. He, and in the bottom left, Schleiden.
Schleiden and Schwann.
Okay, I'm going to start over. I don't think we need the first names.
Yeah.
Matthias
Schleiden. Matthias Jakob Schleiden.
So in the bottom left corner, we have Schleiden, and in the bottom right corner, we have Schwann, and we kind of group those together because collectively they worked in two different areas, but came to the same conclusion. Schleiden, in the bottom left, was a horticulturist. He looked at plant cells and basically through his observations developed a theory that all plants are made of cells. And Schwann was a zoologist. He was looking at animals at the same time and kind of simultaneously came up with the theory that all animals are made of cells. Is there a good way to remember the names?
Well, if you want to talk about their names, you could say that, Schleiden goes sliding down the slide, and he lands in the plants on the ground, and Schwann...
Like grass?
Schwann, sounds like a swan. So
yeah, and a Schwann is a majestic goose.
It is a majestic goose.
That has great powers.
Yes. I think it is important to note about these two guys that they were already studying these fields. It's not like they went into science to make this theory. It was that these two guys were studying their fields, got the newest, latest technology, the microscope, and used it to contribute to cell theory in that one.
Right. So, together, all plants are made of cells and all animals made of cells, and so they kind of are grouped together, Schleiden and Schwann. The fifth guy in the top right corner, and the most recent of all of these people, is Virchow. And he was actually able to observe cell division happen before his eye, looking through a microscope. And so he concluded that all cells come from pre-existing cells, meaning cells produce new cells. And later in the class, we're going to talk about cell division and the mechanisms that go into cell division. You don't need to know the mechanisms of cell division right now. You just need to know that cells have to be a precursor to new cells, which also helps to disprove spontaneous generation because it ensures that once a cell is made, it continues a line of cells, so to speak, and in order for a cell to be made, it has to come from a pre-existing cell.
So let's wrap this up into the actual statements of the cell theory. So there are three statements in the cell theory. They are kind of what we've been talking about. The first one being that all living things are made of cells. That was proven through the work of all of those scientists. The second being that cells are the basic unit of life. And what this one means, or what we can take away from this one, is that at its most simple or its most basic, life is found at the cellular level.
Nothing below the level of a single cell is living. And
Right.
if you remember from a previous lecture, we talked about organismal complexity. We start with the atom, which is the basic unit of matter, and then the atoms come together in predetermined quantities, and atoms make molecules, molecules make compounds, compounds make organic molecules, bigger compounds, and then those are put together into a series of properly structured concentrations to make the cell. Nothing below the level of the cell is alive. We don't say molecules are living. We don't say organic molecules are living. We don't say atoms are living. We don't say subatomic particles are living. the cell is the basic unit of life because it is the smallest unit that is free living by itself.
Right. It's not that the cell is the smallest thing. It is the cell is the smallest living thing.
Right.
And the third and final component of cell theory is that cells come from pre-existing cells. And this is what we were just talking about with Mr. Virchow. Seeing cell division occur, we now know that cells produce more cells, which is what wraps up our development of the cell theory.
So, how is the understanding, or how is our current understanding of cell biology made possible? That is through the use of a microscope. On the far left, you can see that there is what Robert Hooke would have been using, which is a series of really small lenses and a candle light. Moving to the right, you see the advancements made in the microscope that Antoine van Leeuwenhoek would have made. And then all the way on the right, or towards the right of the screen, you see a light compound microscope, which we would use in class. Obviously, major contributions have been made, technological advancements have been made, and we are now able to look at cells on a daily basis in a variety of fields that continue to contribute to deeper understanding of cell biology.
That's all we have for you guys today. Thank you so much for being here.
If you like the video, subscribe to the channel. We'll see ya. Bye.